A stone circle captures the sunrise on one specific morning every year. This precision is not a lucky accident. It is a message carved in rock across thousands of years. Prehistoric monuments around the world are locked in a silent conversation with the sun, moon, and stars, aligned with celestial events that repeat over cycles longer than a human lifetime. The central mystery is not just the alignment itself, but the impossible timescale behind it. To build these structures, someone had to watch the sky for decades, even centuries, noting shifts invisible to any single observer. They then had to pass that knowledge down through countless generations without a single written word, maintaining its accuracy for a future they would never see. By the end of this exploration, you will understand how these ancient sites reveal humanity's first long-term science, a project of patience spanning millennia. We will uncover how cultures from barren deserts to misty islands achieved this feat, and confront the haunting question of what such a deep time perspective meant to them. What does it truly mean to plan for a future you will never inherit? The sky itself is a clock, but its hands move at a pace we can barely comprehend. To understand the challenge these ancient astronomers faced, you must first grasp the rhythm of their celestial calendar. Our planet does not spin perfectly upright like a top. It wobbles very slowly over a cycle of roughly 26,000 years. This wobble is called precession. Imagine a spinning globe that is slightly tilted, and that tilt itself traces a slow, grand circle over millennia. Because of this wobble, the position of the North Star changes over time. The constellations that mark the spring equinox slowly drift backward through the zodiac. A full cycle from one star marking the equinox to that same star returning to the position takes those 26,000 years. This means the sky your great-grandparents saw is subtly, undeniably different from the sky your great-grandchildren will see. And this is just one of the long-term cycles. The moon has its own complex rhythm, an 18.6-year cycle where the points on the horizon where it rises and sets slowly migrate north and south before returning to their starting position. These are not changes you notice in a lifetime. You might live 80 years and see only a fraction of the moon's full dance, or a tiny sliver of the Earth's grand wobble. To see the full pattern, to predict where a star will be in 1,000 years or where the moon will touch the horizon in a century, requires something we take for granted: continuous observation across generations. It requires a chain of watchers, each inheriting the careful notes of their predecessors, each adding their own lifetime of data to a growing celestial map. This is the staggering timescale of their project. They were not just marking the annual sunrise, they were calibrating their monuments to rhythms longer than empires, tracking celestial movements that begin and end over spans of time that make human history look like a brief footnote. The true mystery then becomes not the astronomy, but the anthropology. How do you build a scientific tradition that must outlive every person who contributes to it? How do you encode data in stone so precisely that it remains accurate for centuries, when the very language you speak might evolve or vanish? This is where the stones begin to speak, not of gods, but of a profound and patient pact between the past and the future. This pursuit of deep time observation has a name, a scientific discipline dedicated to listening to what these ancient stones are trying to say. It is called Archaeoastronomy, a field that sits at the crossroads of archaeology and astronomy. Its goal is not to prove ancient aliens or lost super-civilizations, but to understand with rigorous evidence how prehistoric cultures perceived the sky and wove that knowledge into their world. To separate this real science from captivating fiction, we must understand its ground rules. A credible alignment is not just a single stone pointing roughly east. True archaeoastronomy demands statistical significance. If a temple doorway frames the winter solstice sunrise, researchers ask, is this a 1 in 365 chance, or is it a deliberate pattern repeated across multiple sites built by the same culture? It seeks consistency. Did this culture, across generations, keep building their ceremonial spaces to capture the same celestial event? Finally, and most crucially, it requires context. Is there any archaeological or ethnographic evidence that the sun, moon, or a specific star held profound meaning for these people, perhaps in artwork, in burial practices, or in the oral traditions of their descendants? This three-part test, statistics, repetition, and cultural context, forms the backbone of credible research. It transforms a curious coincidence into a compelling argument for intentional design. It tells us we are not just projecting our own patterns onto the past, but carefully decoding a system they left behind. With this framework in mind, the global map of ancient sites transforms from a collection of mysteries into a series of deliberate experiments in long-term memory. From the deserts of Egypt to the plains of Britain, different cultures, with no contact with one another, each wrestled with the same monumental problem: how to make a fleeting observation permanent, and how to make a personal discovery into a legacy for the unborn. Perhaps the most famous test of this idea is the Great Stone Circle on England's Salisbury Plain. Stonehenge is not one monument, but many, built and rebuilt over more than 1,500 years. This staggering timeline is our first clue, a single site that witnessed the rise and fall of entire cultures, yet its celestial purpose was refined, not forgotten. The most famous alignment is solar. If you stand at the center of the circle on the summer solstice, the longest day of the year, you will see the sun rise directly over a massive, solitary stone set outside the circle, known as the heel stone. This alignment is powerful and direct, a celebration of light at its peak, but the other side of the year holds its own meaning. On the winter solstice, the shortest day, the sun sets in perfect alignment with the central altar stone and the great archways of the tallest trilithons, framing the dying light of the year in stone. This duality suggests a deep understanding of the solar cycle, of balance between light and dark, growth and rest, yet the sun was only part of their skyward calendar. The builders also tracked a more elusive and complex rhythm, that of the moon. The outer circle of Stonehenge, marked by the so-called Aubrey holes, may have been a sophisticated lunar computer. Researchers have proposed that by moving markers between these 56 pits, one per year, an observer could track the moon's 18.6-year cycle of extreme positions and even predict lunar eclipses. Think about what that means. An eclipse is a terrifying event if you do not understand it, the moon turning a deep, ominous red. To predict it, you need data. You need to know that after a certain number of years in this long, slow dance, an eclipse becomes likely. No single person could live long enough to see the full pattern repeat more than a handful of times. This knowledge had to be compiled stone by stone, generation by generation. Someone watched and noted the moon's southernmost rise. 50 years later, their grandchild noted it again. A century after that, another watcher connected the dots, realizing this was a cycle that transcended any one life. The very architecture of Stonehenge, from its solar axis to its lunar holes, embodies this generational project. It is not a snapshot of the sky from one year, but a long-term observatory built to monitor celestial movements that unfold over centuries. The stones are a permanent ledger, holding data that oral tradition alone could never preserve with such precision. They built a machine not of gears but of geography and granite to do what their mortal minds could not, to remember across the abyss of time. Across the Irish Sea, another monument speaks to a different facet of this celestial pact, one focused not on grand circles but on a single, breathtaking moment of light. Newgrange is a massive, grass-covered mound older than Stonehenge, older even than the pyramids of Giza. From the outside, it appears as a great silent hill. But within its heart lies a narrow, 60-foot-long stone passage that leads to a central chamber, and above its entrance is a small, ingeniously crafted opening known as the roof box. For most of the year, this opening is just a dark slit in ancient stone, but for a few precious minutes around dawn on the winter solstice, something miraculous happens. As the sun crests the distant horizon, a thin, brilliant beam of sunlight pierces through the roof box. It travels down the long, dark passageway like a laser, finally illuminating the innermost chamber in a pool of golden light for approximately 17 minutes before fading away. This is not a vague alignment. This is precision engineering of light and shadow, a theatrical display orchestrated 5,000 years ago. The engineering challenge here is profound. To make that narrow beam hit the back of the chamber on the correct day required foreknowledge that goes beyond marking the sunrise on a hill. The builders had to understand the sun's precise height in the sky on the solstice, its solar declination. They had to calculate the exact angle and height for the roof box opening and the precise orientation of the long passage so the light would travel its full length. But there is a deeper layer to this puzzle. The Earth's axial tilt changes very slightly over centuries, a subtle effect of precession. This means the sun's exact position on the solstice sunrise shifts minutely over long periods. The alignment at Newgrange is so precise that some researchers believe it was designed for the solstice sun's position, not at the time of its initial construction, but decades or even a century later. This suggests the builders were not just observing the sky, they were predicting its slow dance. They possessed a model of solar movement refined over generations, allowing them to aim their stone telescope not at where the sun was, but where they knew it would be for their descendants. This implies a sacred, multi-generational custodianship. The knowledge required to design Newgrange was not created by one brilliant architect. It was the accumulated data of generations of watchers passed down and refined. And once built, the monument itself demanded a new kind of keeper. Someone or some group had to maintain the integrity of that roof box, clear any debris, and ensure the passage remained unobstructed, year after year, century after century, so that each generation could witness the validation of their ancestors' foresight. That 17-minute burst of light was more than a spectacle. It was a promise kept across time. It was a way of tethering the community to the cosmic cycle, of demonstrating that even in the deepest dark of winter, the light would return, precisely as foretold by those who came before. The roof box was not just a window for sunlight, it was a portal connecting the living to the dead, the present to the future, all synchronized to the heartbeat of the sun. But this precision forces us to confront a difficult question. How can we know any of this was deliberate? The horizon is a circle of 360 degrees. The sun and moon rise and set at slightly different points along that circle every single day. Given enough stones and enough time, some random structure will, purely by chance, point to a major solar event. This is the core challenge of archaeoastronomy, separating a cosmic blueprint from a cosmic coincidence. To move beyond guesswork, researchers build a case for intent using multiple, converging lines of evidence. The first is repetition. A single alignment might be luck, but if a culture builds multiple structures over centuries, and they all consistently frame the same celestial event, the odds of that being accidental plummet. Think of it like finding one arrowhead in a field. It could be a lost tool, but finding a dozen, all shaped the same way and arranged in a pattern that suggests a workshop, a purpose. The second line of evidence comes from the culture itself. Do we find symbols of the sun, moon, or stars in their art or artifacts? Are there oral traditions or later historical accounts that speak of celestial deities or skyward rituals? This cultural context turns an architectural angle into a meaningful gesture. Finally, and perhaps most powerfully, there is the evidence of exertion. How much extra, difficult work did the builders do to achieve this alignment? At Newgrange, the roof box is not a simple hole. It is a carefully engineered channel built with overlapping stones, a technique called corbelling, to create a stable, narrow aperture that would not collapse under the weight of the mound. That specific, labor-intensive design served one primary function: to control a beam of light with millimetric precision. They did not have to build it that way. A simpler entrance would have been far easier. The sheer architectural effort expended is a silent but screaming argument for intent. It tells us the alignment was not an afterthought. It was the central, driving purpose of the entire monumental endeavor. When you find repetition, cultural meaning, and disproportionate effort all pointing in the same direction, the case for chance evaporates. You are left looking at a message, one that required seeing the world not as a place of random events, but as a grand, predictable mechanism. This shift in perception from chaos to cosmos may be their greatest legacy to us. The stones themselves hold another kind of code, one written not in alignment but in geometry. In the mid-20th century, an Oxford engineering professor named Alexander Thom surveyed hundreds of stone circles and rows across Britain and France. What he claimed to find was astonishing: not random piles of rock, but precise geometric shapes, circles, ellipses, and egg-shaped rings, all built to a common standard. His most controversial proposal was the existence of a universal unit of measurement, which he called the megalithic yard. According to Thom, this unit was approximately 2.72 of our modern feet, and it appeared again and again in the dimensions of sites separated by hundreds of miles and built over many centuries. If his analysis is correct, the implications are staggering. It would mean that disparate Neolithic communities from the Scottish Islands to the coast of Brittany were not just independently aligning their monuments to the sky, they were using the same ruler. This suggests a shared, sophisticated system of knowledge, a formalized geometry that could be taught, replicated, and carried across the landscape. Think of it like finding that builders from different countries who never met all used the exact same length for a meter stick. It points to a common source of learning, or at the very least, a highly effective network of communication where complex ideas could travel. This geometry is not separate from the astronomy, it is its essential partner. You cannot reliably build a monument to capture the solstice sunrise if you do not have a consistent way to measure the land, to lay out your sight lines, and to ensure the structure's proportions are stable across generations. Geometry provided the stable framework upon which the moving sky could be mapped. A standardized unit of measure transforms celestial observation from a local tradition into a formal, teachable science. A master builder in Orkney could, in theory, explain the design for a lunar observatory to an apprentice using the language of the megalithic yard and geometric principles. That apprentice could then travel or teach others, carrying a precise blueprint in their mind, a blueprint that was not just about shape, but about function, about locking stone to celestial event. This idea of a formalized, transmissible knowledge system is crucial for our central mystery. It offers a mechanism for how such precise astronomical alignments could be maintained across vast distances and time. It suggests that the watchers of the sky were also master surveyors, that their long-term project was supported by a common technical language. While not all scholars accept Thom's megalithic yard as conclusively proven, the very debate highlights a profound truth. These monuments display a level of planning and consistency that demands some form of organized, accumulated knowledge. They are not the products of isolated inspiration, but of a cultural project that valued precision, repetition, and the faithful transmission of a grand design. The stones, in their size and spacing, may be whispering not just to the sky, but to each other across the hills and millennia, in a language of measure and form that made their celestial calendar permanent. The geometric precision of Britain's circles finds a powerful echo far to the south, on the sun-scorched islands of Malta. Here stand the temples of Mnajdra and Kim, colossal structures of limestone erected over 1,000 years before Stonehenge's first stones were raised. They are among the oldest free-standing stone buildings on Earth, and their architecture reveals a solar calendar of breathtaking intricacy. The lower temple at Mnajdra is a masterpiece of this ancient timekeeping. Its entrance and internal corridors are oriented with such care that on the spring and autumn equinoxes, the very first rays of the rising sun pass directly through the main doorway, flooding the central axis with light in a perfect alignment of architecture and cosmos. But the builders did not stop with the equinox. They designed the temple to capture the solstices as well. On the summer solstice, a slender beam of sunlight enters through a different opening, striking a specific, large stone slab to the left of the central corridor. 6 months later, on the winter solstice, the sunrise shifts, and the beam now illuminates a corresponding slab on the right. This is not a single alignment. It is a calibrated three-point system marking the sun's extreme journey across the year. The effect is like watching a cosmic needle move across a stone dial, with the equinox at the center and the solstices marking the outer limits. To achieve this, the builders needed more than a lifetime of observation. They needed to understand the sun's cyclical path so thoroughly that they could design a permanent, immovable structure to display it. The temples themselves were used for over a millennium, a span of time that saw countless generations come and go. This enduring use points to something critical, a stable cultural institution dedicated to maintaining this knowledge. It strongly suggests the existence of a priestly or scholarly class, individuals who inherited the role of sky watcher and temple keeper. Their duty was not just to conduct rituals, but to be the living memory of the solar calendar. They would watch the sunrise from the same spot, year after year, noting any subtle drift, understanding that their lifetime of observation was merely a single data point in a project spanning centuries. They were the human link in the chain, ensuring that the meaning of those beams of light striking those specific stones was never lost, that the temple's silent testimony remained a living, understood language. This institutional stability transforms the temple from a mere monument into a functioning observatory and a school. It represents a society that invested its resources and its identity in a long-term relationship with the sky, a society that believed preserving this cosmic connection was worth the labor of generations. The light that enters Mnajdra did more than mark the seasons. It validated an unbroken promise between the past and the future, a promise written in sunlight and stone. The Maltese temples were a fixed calendar in stone, but what if the knowledge of the sky needed to travel? In the heart of Germany, a discovery was made that changes our understanding of how this cosmic wisdom was shared. It is called the Nebra Sky Disk, a bronze disk about the size of a dinner plate, inlaid with gold symbols. It is not a monument, but a manual. Dated to around 1,600 years before the Common Era, it is considered the oldest known concrete depiction of the cosmos in the world. On its surface, a cluster of gold dots represents the Pleiades star cluster. A large golden circle and a crescent shape depict the sun and moon, and along its edges are two golden arcs, later added, which most scholars interpret as marking the solstitial points, the sun's traveling range between summer and winter on the horizon. This is not a vague artistic impression, it is a specific, symbolic map of the heavens. Its portability is revolutionary. Unlike Stonehenge or Newgrange, which are rooted to one sacred location, the disk could be carried. It was a physical reference, a standard model of the sky that could be shown, pointed to, and used to teach. Imagine a Bronze Age elder holding this disk, using it to explain to an apprentice the important relationship between the Pleiades, the moon, and the setting sun, a relationship that marked crucial times for planting or ceremonial rites. It codifies generations of naked eye observation into a single, durable object. The knowledge no longer resided solely in memory or in the landscape. It was now held in the hand. This transforms the transmission of knowledge. A complex set of observations about cycles that take decades to comprehend could be summarized and taught using this iconic representation. Furthermore, the disk's design suggests it might have had a practical function. Some researchers propose the arcs could have been used as a simple sighting tool. By aligning the disk with the horizon and observing where the sun set relative to the arcs, a traveler from one region could calibrate their observations with someone from another valley, ensuring their calendars remained in sync. It becomes a tool for standardizing time across a territory. The Nebra Sky Disk represents a leap in the technology of knowledge. It shows a culture moving from building observatories to creating portable models, from embedding knowledge in place to carrying it with them. It is proof that the long-term project of watching the sky had produced a teachable, transferable science, one that could survive the migration of people and the passage of generations, not through stone alone, but through a crafted symbol of the cosmos itself. The portable cosmos of the Nebra disk shows a culture codifying celestial knowledge, but another site takes this idea to its ultimate architectural conclusion. In the coastal desert of Peru, the ancient people we call the Ceque culture built something that is neither a temple nor a dwelling, but a pure, unadorned machine for watching the sun. It is called Chankillo, and it consists of 13 nearly identical stone towers, built in a neat north-south line along the spine of a low hill. From a distance, they look like the jagged teeth of some great stone creature, but their purpose was one of sublime precision. At either end of this line, about 200 meters to the east and west, the builders constructed two distinct observing points. If you stand at the western observation point and look toward the towers at dawn, you witness a solar calendar carved into the landscape. As the sun rises throughout the year, it appears to move along the horizon, emerging from behind a different tower each day. On the June solstice, the sun rises at the far right or southernmost tower. It then slowly shifts northward, rising behind each successive tower until it reaches the far left or northernmost tower at the December solstice before beginning its journey back again. The eastern observation point provides the mirror image for sunsets. This is not a symbolic alignment. It is a functional, horizon-based calendar with a resolution of just 1 or 2 days. Each tower marks a specific date in the solar year, and the entire line provides a public, immutable reference for an entire society. The genius of Chankillo is in its clarity and its dedication. Unlike a temple where the alignment is a feature within a sacred space, here the entire structure is the instrument. There are no living quarters, no burial chambers, no grand plazas for large gatherings. It appears to have been built for one purpose only, to observe and standardize solar time. This suggests the existence of a formalized, perhaps even bureaucratic, approach to timekeeping. A designated observer, likely a priest or astronomer, would have taken a position at the western post each dawn, noting which tower framed the sun. That single observation would tell everyone in the valley the exact day within the agricultural and ceremonial cycle. It removed ambiguity. It turned the complex, abstract motion of the sun into a simple, undeniable fact, visible to all who understood the code of the towers. This was a society investing immense labor, not in a monument to a ruler or a god, but in a tool for synchronizing collective life to the cosmic rhythm, a tool meant to function flawlessly for centuries. The 13 towers of Chankillo stand as perhaps the most honest expression of humanity's long-term project, a permanent stone dial built to keep a civilization in time with its star, generation after generation after generation. The stone towers of Chankillo are a calendar you can see, but some cultures built their celestial clock inside the human mind, far across the ocean, in the rainforests of Mesoamerica, the Maya developed an astronomical science so precise it was encoded not in megaliths, but in mathematics and writing. Their great pyramids and temples are often aligned to celestial events, but their true legacy of long-term observation is found in the bark paper pages of codices and the carved dates on stone stelae. The Maya did not just watch the sky, they recorded its movements with obsessive detail, creating a predictive model of the cosmos that stands as one of humanity's great intellectual achievements. Their solar year calculation, the Hab, was refined to 365.2420 days, astonishingly close to our modern value of 365.2422. This precision did not come from a single lifetime of watching sunrises. It was the result of centuries, perhaps millennia, of priest astronomers meticulously comparing calendar dates with the actual position of the sun, making tiny, cumulative corrections across generations. They tracked the sinuous path of Venus with even greater accuracy, calculating its 584-day synodic cycle to within a few hours. They understood that 5 Venus cycles very nearly equaled 8 of their solar years, a period they considered of great ritual importance, weaving the movements of the morning star into their sacred narratives and the timing of royal ceremonies. Most impressively, they learned to predict eclipses by carefully recording the intervals between lunar and solar eclipses over vast stretches of time. They identified the repeating pattern of the Saros cycle, a period of approximately 18 years. Their Dresden Codex contains tables that allowed them to forecast these ominous events, transforming a terrifying celestial phenomenon into a predictable and therefore controllable part of the cosmic order. This predictive power was the ultimate fruit of their generational project, but the most profound expression of their deep time perspective is not a calculation, but a conceptual framework, the long count calendar. While we mark years from a fixed point in the past, the Maya conceived of time in grand, rolling epochs. Their basic long count unit, the Bacton, spans 144,000 days, nearly 400 of our years. They saw history and prophecy unfolding across these immense Bacton cycles, with their mythology and cosmology structured around completions and renewals of these great ages. The famous turn of the 13th Bacton in 2012, widely misunderstood as a prediction of an end, was actually, in the Maya view, the conclusion of one major epoch and the beginning of the next. This calendar system reveals a culture whose intellectual horizon was not the harvest or the reign of a king, but the slow, majestic turning of cosmic eras. Their mindset was inherently millennial. To achieve their astronomical precision, they had to think in scales that dwarfed individual lifespans, trusting that the data they inscribed on stone or bark would be used by scholars 100 or 500 years later to maintain the celestial harmony of their world. Their legacy is a powerful reminder that the long-term observation of the sky can produce not just monuments, but a complete and sophisticated scientific philosophy, a way of being in time that is both humbling and awe-inspiring. Deep in the arid hills of southeastern Turkey, a discovery has rewritten the opening chapter of human civilization. Göbekli Tepe is not a city nor a fortress, but a series of circular enclosures built from massive, T-shaped limestone pillars, some standing over 16 feet tall and weighing more than 10 tons. What makes this site utterly staggering is its age, carved from the bedrock over 11,000 years ago, a full 6 millennia before Stonehenge. This was the work of hunter-gatherers, people who had not yet invented pottery, permanent agriculture, or metal tools. And yet, they came together to undertake one of the most ambitious construction projects the world had ever seen. The pillars themselves are eerily humanoid, with carved arms and hands meeting at the waist, suggesting stylized ancestors or watchful beings. Many are adorned with intricate bas-reliefs of animals, scorpions, foxes, birds, and fierce predators, a menagerie frozen in stone from a lost world. For decades, the purpose of these mysterious rings has been debated, but a compelling thread of evidence now points skyward. Researchers studying the layout of the enclosures have proposed that the central pillars in certain rings are precisely aligned. One enclosure seems oriented toward the point on the horizon where the star Sirius would have risen around 9,000 years before the Common Era. Another may frame the solstice sunrise. If these alignments are indeed deliberate, the implications are seismic. Göbekli Tepe would represent the very dawn of coordinated astronomical observation, the first known spark of a tradition that would eventually illuminate the globe. This means the long-term project did not begin with farmers or kings, but with nomadic bands who looked at the wandering stars and felt a need to anchor them in stone. They were not marking time for harvests as they had no crops to sow. They were perhaps creating a cosmic anchor point, a place where the community could gather to reaffirm its place in a universe of spirits and stars. The effort required is almost incomprehensible, quarrying, carving, and transporting these monoliths using only stone tools and human muscle, all for a site that was deliberately buried after centuries of use. This was not a practical undertaking, it was a sacred one, born from a desire to build something permanent that spoke to the eternal cycles above. Göbekli Tepe stands as a profound question in stone. If the first temple humanity ever built was also an observatory, then perhaps our urge to understand the sky is woven into the very fabric of what makes us human. While the stones of Göbekli Tepe stand in silent testimony, another culture was inventing a different and perhaps more durable method for preserving the whispers of the sky. In the fertile plains of the Yellow River Valley, the Shang dynasty of ancient China developed a system that turned celestial observation into a written science. Their tool was not granite but bone. During the second millennium before the Common Era, Shang diviners would inscribe questions onto the shoulder bones of oxen or the flat undersides of turtle shells. They would then apply intense heat until the bone cracked, and a royal diviner would interpret the pattern of fractures as an answer from the ancestral spirits. These questions covered every aspect of statecraft, from the outcome of battles to the success of the harvest, but among the most common inquiries were those about the sky itself. Will the sun be eclipsed? Will the moon be eclipsed? Is the appearance of this strange new star auspicious? After the ritual, the date, the question, and sometimes even the actual outcome were all meticulously carved into the bone itself. A typical inscription might read, "Crack making on day Giyu, the king divined, in the next 10 days will there be disaster. On day Junction, a new star appeared beside the Heart constellation. That night, a great fire was seen in the west." This was not poetry or myth, it was a dated, factual record. Over centuries, thousands of these oracle bones were produced and stored, creating an unprecedented written archive of celestial events. For the first time in human history that we know of, an eclipse was not just a terrifying memory to be passed down in story. It was a line of text attached to a specific day in a 60-day cycle. A nova, a new star blazing suddenly in the heavens, was logged with its position among the familiar constellations. This practice transformed astronomy. Oral tradition is fluid, details shift and exaggerate over generations, but writing freezes a moment. A diviner 100 years later could consult the stored bones and see that a solar eclipse had occurred on a day named Jayasi during the 5th month of a certain king's reign. By comparing multiple such records, patterns began to emerge from the archive. They could start to see that eclipses were not random acts of celestial anger, but events that followed a rhythm that could be studied and eventually anticipated. The oracle bones became a database, a cross-referenceable library of the sky's behavior. This allowed Shang astronomers to think in cycles longer than any living memory. They could compile data across reigns, across lifetimes, building a model of celestial mechanics that was empirical and cumulative. The act of divination, seeking meaning from the spirits, had accidentally created the foundation for a long-term scientific project. The cracks in the bone were seen as messages from the ancestors, but the inscriptions themselves became a message to the future, a permanent ledger ensuring that no celestial event, no matter how rare or frightening, would ever be truly forgotten. The sky was being decoded, one carefully inscribed character at a time. High in the Andes, the Inca Empire stitched its astronomy directly into the landscape. Their most iconic celestial instruments were the Intihuatana stones, whose name translates to the hitching post of the sun. At sacred sites like Machu Picchu, these are not simple markers, but exquisitely carved granite pillars rising from a smooth stone base. They functioned as sophisticated gnomons, the central pin of a sundial. On the solstices, the sun would cast no shadow at noon from the pillar's central edge, or its shadow would align perfectly with carved grooves or other architectural features, symbolically tethering the sun at the peak or turn of its journey. This was a moment of profound ritual significance, a demonstration that the emperor, the Sapa Inca, could literally bind the celestial ruler to the earth. But the Intihuatana was more than a solstice detector. It was the heart of a much larger observational system. The Incas practiced horizon astronomy from mountain summits, using the jagged peaks of their sacred apus or mountain spirits as a natural calendar. They would watch from specific stones as the sun or certain stars rose or set behind distinct notches in the distant mountains, marking agricultural dates and ceremonial times with a precision tied to local topography. This knowledge was not held by a few. It was woven into the empire's very structure through the Ceque system, radiating out from the Coricancha, the golden temple of the sun in Cusco, were 41 invisible but precisely maintained lines called ceques. Each ceque was a conceptual line that connected a sequence of sacred spots or huacas, which could be springs, stones, tombs, or temples. These lines were not just spiritual, they were administrative and astronomical. Each ceque was the responsibility of a specific clan or social group, who maintained its huacas and performed the rituals associated with them. Crucially, many of these lines also functioned as sightlines to key points on the horizon where the sun, moon, or important stars like the Pleiades would rise or set on significant dates. This was a stroke of genius for long-term preservation. By making astronomical observation a mandatory social duty tied to lineage and land, the Incas ensured the knowledge would be maintained. A clan's identity was linked to watching a specific mountain notch for the Pleiades' heliacal rising, which signaled the planting season. If they failed in this duty, they failed their ancestors and their empire. The Ceque system transformed the entire valley of Cusco into a living, breathing observatory and calendar, its data preserved not in writing, but in social obligation and sacred geography. Astronomy was no longer a specialized science. It was the operating system of the state, a collective memory built into the duties of every citizen, guaranteeing that the watch on the sky would continue unbroken for as long as the empire itself endured. The Ceque system of the Incas wove astronomy into the very fabric of society, but on another continent, a different solution emerged, one built from a material that would not last. In the heart of what is now Illinois, near the Mississippi River, the great city of Cahokia once thrived. At its peak around the year 1050 of the Common Era, it was larger than London at the time, a bustling metropolis of mounds, plazas, and tens of thousands of people. And on its western edge, archaeologists discovered something remarkable: the patterns of large, evenly spaced post holes forming a perfect circle. This was Cahokia's Woodhenge, a horizon calendar crafted not from stone but from towering cedar posts. The reconstruction shows a circle roughly 410 feet in diameter, with posts set at key points around its circumference. At the circle's center stood a special council house, likely a place for leaders and priests. From this central vantage, the entire circle became a precise instrument. On the morning of the equinox, an observer inside that council house would have seen the sun rise directly over a post set in the eastern arc of the circle. On the summer solstice, the rising sun would align with a different post to the northeast, and on the winter solstice, yet another to the southeast. The wooden posts acted as permanent sighting markers against the moving backdrop of the sun, turning the entire landscape into a calibrated calendar. The genius of this design was its public clarity. Unlike a dark passageway or a secluded mountaintop, this was an open, communal space. The alignment was not a secret for a few, but a visible event for many, a way to synchronize the entire city's agricultural, ceremonial, and social life to the solar year. But wood, unlike stone, rots. A cedar post, even a massive one, might last a few decades before it weakened and had to be replaced. This impermanence is where the deeper story lies. Woodhenge was not a one-time construction. It had to be rebuilt perhaps every generation or so. Think of the profound ritual this would have created. When a key post decayed, the community did not just replace it with a new one in the same hole. Evidence suggests they sometimes shifted the entire circle slightly, recalibrating it. This means the elders who remembered the old alignments had to work with the new builders, using their knowledge of the sun's current path to ensure the new posts captured the solstice sunrise with the same accuracy. The act of rebuilding was not mere maintenance, it was an act of collective memory. It forced the transmission of precise astronomical knowledge from one generation to the next in a very hands-on, practical way. A young apprentice would learn not just by listening, but by helping to hold the new post, by watching where the elders pointed to on the horizon, by participating in the ceremony that validated the alignment as the sun crested the post on the appointed morning. This cyclical renewal made the calendar a living tradition. The knowledge was not locked in immutable stone, it was refreshed and reaffirmed through shared labor. Each rebuilding of Woodhenge was a promise to the future, a commitment that the people of Cahokia would keep their world in harmony with the cosmos, no matter how many generations passed. The wood itself was perishable, but the act of raising it again and again made the knowledge eternal. The wood of Cahokia may have decayed, but the stone of Egypt endures. While the solstice sun famously illuminates inner chambers at sites like Newgrange, the pyramids present a different, even more demanding kind of alignment. Their four faces are oriented to the cardinal directions, north, south, east, and west, with an accuracy that still baffles engineers. The Great Pyramid of Giza, for instance, is aligned to true north with an error of just 3/60ths of a degree. To achieve this, its builders did not simply watch the sunrise. They needed a fixed, unchanging reference point in the night sky, and they found it in the silent, circling stars. This introduces one of the most debated ideas in archaeoastronomy, the Orion correlation theory. It proposes that the layout of the three main pyramids at Giza mirrors the three stars of Orion's belt, and that the Nile River corresponds to the Milky Way. The theory is visually compelling, suggesting the pharaohs aimed to create a cosmic map on the ground. However, many astronomers and Egyptologists point out significant issues. The match is not perfect. The relative sizes and positions of the pyramids do not align precisely with the stars' brightness and spacing, and the celestial landscape shifts over millennia due to precession, meaning the correlation would have been closer at different times in history. While the grand celestial map idea remains controversial, there is far stronger, less speculative evidence for stellar alignments. Deep within the Great Pyramid are narrow, angled shafts that emanate from the king's and queen's chambers. For a long time, their purpose was a mystery. We now understand these were not air vents, but sight lines to specific stars. The southern shaft from the king's chamber pointed directly to the star Al-Nitak, the brightest star in Orion's belt, a constellation intimately associated with the god Osiris, lord of the afterlife. The northern shaft targeted Thuban in the constellation Draco, which was the pole star at the time of the pyramid's construction around 2500 BCE. These shafts were not for living observers to look through. They were symbolic pathways designed to allow the pharaoh's soul to ascend directly to these imperishable, eternal stars. This reveals a profound astronomical intention. To build these shafts, the architects needed precise knowledge of the star's altitude in the sky at that specific latitude and epoch. That knowledge could only come from a sustained, generations-long program of observing and recording the nightly drift of these circumpolar stars. Even more telling is the foundational precision of the pyramids themselves. Before a single block was set, the builders had to establish a perfectly level base and then orient the entire massive square to the cardinal points. Egyptologists believe they used a method called the simultaneous transit of two stars. An observer would mark the position of a star as it rose on the eastern horizon and another as it set directly opposite on the western horizon. By bisecting this angle, they could find true north. But to do this with such minute error required watching not just any stars, but specific circumpolar stars that never set, tracking their slow rotation around the celestial pole over many nights, and refining their measurements year after year. This was not a one-time project. This standard of precision was maintained across pyramids built over centuries. Such continuity was possible only because of the unique stability of Egyptian civilization, which lasted for over 3,000 years. This longevity provided the essential framework for a long-term astronomical tradition. A priest astronomer in the Old Kingdom could build upon observational records passed down from his predecessors and trust that his own work would be preserved and used by the temple scribes and architects of the Middle Kingdom centuries later. The state-sponsored temples became the repositories of this cumulative knowledge. The pyramids, therefore, are more than tombs. They are the ultimate expression of a culture that had mastered the art of thinking across centuries. They represent a covenant with eternity, built by people who looked to the timeless stars to anchor their legacy in a world they knew was always changing. The silent stones and star shafts we have explored present a profound logistical puzzle. If these cultures achieved such precision without a written manual, how did the knowledge survive the relentless passage of time, the rise and fall of leaders, the migrations and conflicts that define human history? The answer lies not in libraries of parchment, but in the human mind itself, trained through generations into a living, breathing repository. For millennia, the primary technology for long-term data storage was oral tradition, a system far more sophisticated than simple storytelling. It was a disciplined craft using rhythm, rhyme, ritual, and rigid formula to encode complex information into forms that were unforgettable. Think of it like a song you cannot get out of your head, but one that contains the precise instructions for navigating an ocean or predicting a season. The Polynesian voyagers who settled the Pacific Ocean provide a stunning example. They crossed thousands of miles of open water without compasses or charts, guided by the stars, swells, and bird flights. Their knowledge was preserved in detailed chants passed from master navigator to apprentice. These chants were not poems about the sea, they were operational manuals. They listed the succession of stars that would rise over a specific island at different times of the year. They described the feel of particular ocean currents and the patterns of clouds that formed over distant land. The chant structure, its very meter and melody, acted as a mnemonic framework, ensuring that a star's name, its bearing, and its seasonal relevance were recalled as a single, unbreakable unit. An error in recitation was not just a mistake in performance, it could mean sailing off into oblivion. This imposed a ruthless standard of accuracy on the oral tradition. Similarly, the Aboriginal Australian concept of the songline reveals how landscape and sky were fused into a single memory system. A songline is a sequence of locations, landmarks, waterholes, and celestial events linked together in a narrative song. As an elder travels the land singing the song, each verse corresponds to a specific feature in the terrain and often to a particular star or constellation overhead. The song does not merely describe the land, it is a map and a calendar. By singing the song in the correct order, one can navigate across vast distances. By knowing which part of the song is sung when a certain star appears, one knows what season it is, where food and water will be found. The knowledge is not owned by an individual, it is held in trust by the community and performed, literally walked and sung, into each new generation. The ritual act of performance is what keeps the data alive and uncorrupted. In these systems, myth was not opposed to science, it was its delivery mechanism. A story about a hero chasing a kangaroo across the sky might encode the observed path of the Milky Way throughout the year. A ceremonial dance reenacting a cosmic battle might mark the equinox. The narrative provided context, emotion, and meaning, making the dry observational data essential to cultural identity and survival. Forgetting a verse was not just losing a story, it was losing a crucial waypoint on a journey or missing the signal to plant seeds. This cultural imperative for perfect recall created what we might call living libraries, individuals trained from childhood to become the custodians of specific knowledge bundles. Their lifetime's work was to hold one piece of the celestial puzzle with absolute fidelity, ready to pass it on when the time came. The monument, then, was not a replacement for this oral system, but its anchor. The stone circle or the temple alignment provided the physical proof, the immutable reference point against which the songs and stories could be periodically checked and corrected. The oral tradition carried the dynamic, detailed knowledge across generations, while the stone guaranteed its permanent truth. Together, they formed a fail-safe system, a dual-layer backup for humanity's most precious data, the clockwork of the cosmos itself. These living libraries did not maintain themselves. The flawless transmission of celestial knowledge across centuries almost certainly required a dedicated class of custodians. In every culture we have examined, from the priestly watchers in the Maltese temples to the Inca clans guarding their Ceque lines, we see a common thread: specialization. This was not a hobby for farmers in their spare time. It was a full-time vocation, a societal role granted immense prestige and authority. These individuals, whether called priests, shamans, astronomer kings, or master navigators, formed the essential human infrastructure of the long-term project. Their primary duty was to watch, to remember, and to teach. By being freed from the daily labor of farming or hunting, their minds could be dedicated entirely to the slow accumulation of data, to noting the subtle drift of a star's rising point over a decade, or to memorizing the complex oral formulas that contained generations of observations. This specialization created a protected lineage. Knowledge was passed from master to apprentice in a formal, often secretive, chain of custody. An elder astronomer would select a promising young student, not just for their intelligence, but for their character and their capacity for disciplined memory. The training was rigorous, a lifelong immersion in ritual, mathematics, and sky lore. This system insulated the knowledge from the chaos of everyday life. While a village might be concerned with this year's harvest or a local conflict, the celestial custodians were tasked with a timeline that transcended all of that. Their work was for the next generation and the one after that. This long horizon granted them a unique form of authority. They could command the labor and resources needed to build a Stonehenge or a pyramid because they spoke for a timescale beyond any chieftain's reign. They were the bridge between the present community and the ancestral past, and the guarantors of its future harmony with the cosmos. When a priest announced it was time to rebuild the wooden posts at Cahokia or to reorient a temple axis, the people listened, not just out of fear, but out of a shared understanding that this person held the keys to continuity itself. Their authority was rooted in their role as keepers of the calendar, the individuals who could declare the correct day for planting, for ceremony, for renewal. In this way, the celestial science gave birth to a social institution, and that institution, in turn, ensured the science would endure. The stones and stars provided the constants, but it was this human lineage, this unbroken chain of watchers, that turned observation into a legacy. This deep time science was never just about philosophy or the stars. It was a matter of life and death. The celestial calendar was the most vital piece of social glue any early society possessed, a foundational technology for survival itself. Its precision was not an intellectual luxury. It was a practical necessity that demanded generational investment. At the most basic level, it was about food. Knowing precisely when to plant seeds was not a suggestion. It was the difference between a bountiful harvest and starvation. The sun's journey marks the seasons, but a simple observation of spring's warmth is not enough. A late frost can destroy newly sprouted crops. Ancient farmers needed a reliable, long-term predictor, a signal that came not from the uncertain earth, but from the dependable sky. They learned that the heliacal rising of a specific star cluster, like the Pleiades just before dawn, consistently heralded the safe time for planting. But to trust that signal, you had to be certain it was true year after year, decade after decade. That required confirming the pattern over lifetimes, ensuring that the celestial cue and the climatic window remained locked together. This was a multi-generational agricultural experiment. A grandfather would note the star's appearance and the subsequent weather. His grandson would do the same 50 years later, adding to the data. Only after centuries of such observation could a community stake its survival on that heavenly alarm clock with absolute confidence. The calendar also governed the movement of life beyond the fields. For hunter-gatherer and pastoral societies, predicting the migrations of herds or the spawning runs of fish was essential. These events are tied to subtle, annual cycles of light and temperature, cycles best tracked by the unwavering motion of celestial bodies. Knowing when the caribou would arrive or when the salmon would fill the river required a calendar refined over generations, one that could account for slow environmental shifts. Furthermore, as societies grew larger and more complex, the calendar became the schedule that held everything together. It dictated when distant clans should gather for ceremonies that reinforced social bonds. It established the dates for regional trade fairs when goods and ideas could be exchanged across vast distances. It set the times for paying tribute or taxes, often tied to the harvest, creating a predictable rhythm for the economy and governance. Without a shared, accurate calendar, these activities descend into chaos. You cannot coordinate a planting festival if one village thinks it is the week of the equinox and another is already a month past it. The calendar synchronized human activity on a massive scale, turning scattered groups into a cohesive civilization. This is why the investment in precision was so profound. A calendar that drifted by even a few days over a century would eventually put planting time in the wrong season, misalign ceremonies with celestial events, and fracture social agreements. Maintaining its accuracy was therefore a sacred, practical duty. The stones and posts and sightlines were not just monuments, they were public utilities, vital infrastructure for collective survival. They ensured that the hard-won knowledge of when to act, passed down from ancestors who had watched the sky for centuries, would remain true for the children yet to be born. The calendar was the operating system of society, and its long-term observation was the endless, critical work of keeping that system updated and running. But this quest to find meaning in ancient stones can lead us down a path where evidence grows thin and speculation takes flight. The field of archaeoastronomy has its own frontier, a zone of claims that test the very limits of what we believe prehistoric observers could have known. Here we encounter alignments not to the sun or moon, but to the slowest and grandest celestial clock of all, the precession of the equinoxes. This 26,000-year wobble shifts the entire backdrop of stars against which the sun rises. Some researchers propose that certain monuments were built to mark not just a solstice sunrise, but the precise moment in this multi-millennial cycle when the sun rose against the backdrop of a specific constellation, like Taurus or Leo, at a key date like the equinox. The most famous of these speculative ideas involves the Great Sphinx of Giza. A theory suggests that because the Sphinx faces due east, it would have gazed directly at the constellation Leo, rising on the spring equinox around the year 10,500 BCE, an era far older than conventional dating for the monument. Proponents see this as evidence of a lost, advanced civilization. Mainstream archaeology and astronomy, however, raise serious objections. The geological erosion patterns used to support such an early date are heavily debated. More critically, the concept of zodiacal constellations as we know them, like Leo the Lion, is a much later invention from Mesopotamia and Greece. The ancient Egyptians organized their night sky into different star groups and decans. To say the Sphinx aligns with Leo imposes a foreign symbolic system onto a culture that did not use it. This is a crucial lesson, the danger of projecting our modern celestial maps onto the past. Another star-based claim centers on the Great Pyramid's so-called air shafts. While their alignment to stars like Thuban in the era of construction is widely accepted, some have pushed further. They suggest the pyramid's layout encodes the positions of stars from an even more remote epoch, perhaps aligning with the star Alpha Draconis, as it was the pole star thousands of years before the pyramid was built. The evidence for this is highly circumstantial, relying on complex numerical coincidences between pyramid dimensions and celestial distances, a practice called numerology that most scholars dismiss. The difference between a strong alignment and a speculative one often comes down to cultural context and statistical rigor. A solstice alignment at a temple used for 1,000 years is a repeated, functional fact. An alignment to a precessional cycle that only occurs once every 26,000 years is a one-time event with no clear practical or ceremonial purpose for a society that would never see the cycle complete. It moves from observable, repeatable science to a grand, untestable assertion. These fringe theories, while captivating, serve an important purpose. They define the boundary of the field. They force us to ask harder questions. What constitutes proof? How do we avoid seeing patterns we want to see? The most credible research always returns to the triad of evidence, multiple examples, cultural meaning, and signs of deliberate, disproportionate effort. When we step over that line into the realm of the singular, the symbolic without context, or the numerically coincidental, we leave behind the solid ground of generational observation and enter the realm of myth-making. Yet, even in dismissing the most extreme claims, we must acknowledge the awe that inspires them, the sheer human desire to find a key that unlocks a deeper, older wisdom in the silent stones. That desire itself is a testament to the power of the genuine mysteries that remain. Yet this entire project rested on a foundation far more fragile than stone, the continuity of culture itself. For all their sophistication, many of these celestial traditions did not last. The very societies that achieved such staggering feats of long-term observation often vanished, or their knowledge was lost in the upheavals of history. This is the abandonment paradox. Generations had poured their collective intellect into building a bridge to eternity, only for that bridge to collapse into silence. Consider the Maya. Their astronomical science was arguably the most advanced in the ancient world, with calendars tracking celestial cycles over millions of days. Then, between the 8th and 9th centuries, their great lowland city-states were largely abandoned. The precise causes are still debated, a likely combination of prolonged drought, environmental strain from overpopulation, and social conflict. Whatever the catalyst, the result was a catastrophic rupture. The scribes who could read the codices, the priests who could interpret the Venus tables, the architects who understood the alignments of the pyramids, they were gone. The knowledge became inert, locked in glyphs no one could decipher, in buildings whose celestial purpose was forgotten. The forest reclaimed the plazas, and the long count of days simply stopped. A scientific tradition built over 1,000 years was fractured in a few generations. Similarly, across Europe, the great age of megalithic building came to an end. The cultures that raised Stonehenge and the alignments of Karnak faded, absorbed by new peoples with different beliefs and technologies. The precise meaning of the stones, the oral chants that explained the lunar cycles tracked by the Aubrey holes, the social institutions that coordinated the labor, all of it dissipated like mist. The monuments remained, but their operating manual was erased. This loss forces a sobering realization. Creating these alignments required more than intelligence and patience. It demanded an extraordinary degree of cultural stability. It required a society confident enough in its own future to invest in projects it would never see completed. It needed a social contract so strong that a son would trust his father's celestial measurements, and a grandson would trust his grandfather's and feel obligated to add his own data for a great-grandchild he would never meet. This kind of intergenerational covenant is incredibly rare in human history. It can be shattered by climate change, by invasion, by resource depletion, by a fundamental shift in beliefs. When that stability crumbles, the long-term project is the first thing to go. The daily struggle for survival eclipses the slow watch of the stars. The specialized class of keepers disperses. The oral tradition, that living library, falls silent when there is no one left to teach, or when the students are no longer listening. The stones, then, stand as monuments to a specific and precious set of conditions, a golden age of continuity. Their silence today is not a mark of their failure, but a testament to just how difficult it is to maintain a conversation with the cosmos across the centuries. They remind us that knowledge, even knowledge carved in granite, is not permanent. It is a flame that must be tended carefully and deliberately by each new generation, or it will simply go out. This paradox of lost knowledge reveals a truth about our own era. We are not so different from those ancient watchers. Today, we face scientific challenges that demand the same patient, multi-generational perspective they mastered millennia ago. Modern climate science is a perfect example. To understand the patterns of global warming, researchers cannot rely on a decade of weather data. They need centuries, even millennia, of information. They drill deep into ice cores in Antarctica, extracting ancient air bubbles trapped in layers of snow that fell over hundreds of thousands of years. Each layer is a time capsule, a record of the Earth's atmosphere from a time before human civilization. No single scientist lives long enough to witness the full story those ice cores tell. The project relies on the careful work of generations, from the pioneers who first developed the drilling techniques to the teams today who analyze the data with advanced technology, all contributing to a model of planetary change that unfolds on a clock far slower than our own. Similarly, astronomers monitoring the slow death of a star, or biologists tracking the evolution of a forest over a century, are engaged in the same fundamental practice. They are building upon the observations of those who came before, with the explicit hope that their own work will provide a foundation for those who come after. This is the essence of long-term science, a relay race of discovery where the baton of data is passed forward into a future the original runners will never see. The prehistoric astronomers were the first to run this race. Their motive was not climate modeling but cosmic harmony. Their tools were stone and memory rather than satellites and supercomputers. Yet the core challenge was identical: how to maintain an unbroken chain of observation and meaning across the relentless turnover of human lifetimes. They invented the very concept of a multi-generational project. Their solution, embedding knowledge in monumental architecture and rigorous oral tradition, was the ancient equivalent of our peer-reviewed journals, our digital archives, and our international research institutions. It was a social technology designed to defeat time. When we look at a graph showing 1,000 years of temperature data, or a satellite image tracking glacial retreat over decades, we are seeing the modern expression of that same ancient impulse to look beyond the horizon of our own lives and seek understanding in patterns that only time can reveal. Their legacy is not just in the stones that align with the sun, but in the very idea that humanity can and must think in scales larger than itself. The silent stones hold their secrets, but we are no longer limited to staring at them under a modern sky. A quiet revolution in archaeology is happening not in the field, but inside powerful computers. Researchers now use digital tools to wind back the cosmic clock, testing alignment theories with a precision our ancestors could only dream of. This is the world of simulation and digital archaeology. At its core is a simple but powerful concept. If we can recreate the exact position of the sun, moon, and stars on any given day in the distant past, and then superimpose that sky onto a precise three-dimensional model of an ancient site, we can see what the builders saw. The process begins with laser scanning. Instruments like LiDAR map a site down to the millimeter, capturing every slope, every stone, every subtle contour of the horizon. This data becomes a hyper-accurate digital twin. Into this virtual landscape, researchers plug astronomical simulation software. These programs calculate the positions of celestial bodies for any date, accounting for the slow wobble of precession, the moon's complex orbit, and the subtle changes in the Earth's tilt over millennia. Suddenly, a researcher sitting at a desk can stand at the virtual center of a stone circle on a morning 4,000 years ago. They can watch the sunrise creep across the digital horizon and see if it truly aligns with that specific notch between two stones. They can track the path of Venus over a reconstructed temple or watch the Pleiades rise above a simulated mountain peak. This technology acts as a powerful filter for coincidence. By running thousands of simulations, shifting dates and viewpoints, scholars can statistically determine how likely it is that an alignment occurred by random chance. If the sun only hits the target corridor on the winter solstice, and on no other day of the year, the case for intent grows exponentially strong. Perhaps the most profound gift of this digital toolkit is the ability to strip away modern pollution, both literal and figurative. It removes the light pollution that obscures our view of the stars today. More importantly, it removes our modern assumptions. We can finally see the celestial landscape not as we know it, but as they knew it. We can visualize which stars were the brightest in their night, which constellations held meaning in their mythology, and how the Milky Way arched over their sacred spaces. This shifts the question from, does this stone point somewhere, to what did this alignment mean to the people who built it? Digital archaeology does not provide the cultural answer, but it rigorously defines the astronomical question, separating celestial blueprints from captivating accidents with the clear light of simulated data. These celestial blueprints, recovered through laser light and simulation, deliver a verdict that is both humbling and revolutionary. For centuries, the popular imagination has painted our prehistoric ancestors in broad, simplistic strokes. They were often seen as primitive, living purely hand-to-mouth, their minds consumed by the daily struggle for survival, with little room for abstract thought or long-term planning. The evidence etched in stone across the globe shatters this outdated view completely. What we are seeing is not the work of simple people, but of sophisticated cultures operating on a timescale that challenges our own modern patience. To coordinate the multi-generational labor required to build a Stonehenge, to encode the 18.6-year lunar cycle into architecture, or to calibrate a temple roof box for a solar position decades in the future requires a quality we deeply admire: foresight. It requires a society capable of deferred gratification on a monumental scale. The community that quarried the first sarsen stone for Stonehenge knew they would never see it erected. The child who learned the chant about the Pleiades knew they were memorizing a calendar for their great-grandchildren. This is not the mindset of a people merely reacting to their environment. It is the mindset of custodians, of planners, of astronomers who saw themselves as links in a chain stretching far into both the past and the future. They possessed a deep time consciousness that is profoundly modern, even if their tools were ancient. Furthermore, the precision of their work reveals a sophisticated grasp of geometry and mathematics. Whether it was the possible megalithic yard, the precise bisecting of angles to find true north for a pyramid, or the geometric ratios embedded in their monuments, they were manipulating abstract concepts of space, angle, and number. They were doing long division with tons of stone. This was not magic or random piling of rocks. It was applied mathematics, a technical language used to translate celestial motion into terrestrial form. To call this primitive is to fundamentally misunderstand the word. Their technology was different, rooted in stone, wood, and memory, but their intellectual ambition was immense. They asked the biggest questions about time, order, and humanity's place in the cosmos, and they devised stunningly elegant, durable answers. They invested the collective effort of centuries not in monuments to war or conquest, but in a shared project of understanding. This shift in perspective is perhaps the greatest gift of archaeoastronomy. It asks us to replace the condescending label of primitive with more accurate and respectful terms, like meticulous observer, long-term philosopher, or generational scientist. They looked at the chaos of the night sky and saw a pattern. They then made a pact with their unborn descendants to preserve that pattern forever. In doing so, they left behind a powerful question for us. In our age of fleeting digital data and short-term thinking, what are we building that will speak of our understanding to the people of the year 4000? Across the deserts of Peru, the plains of Britain, and the islands of Malta, a singular pattern emerges from the silent stones. These cultures, separated by oceans and millennia, were all solving the same fundamental problem with strikingly similar tools. They were architects of time, and their blueprints reveal a shared human grammar written in sunlight and shadow. The first and most universal thread is the solar anchor. From the 13 towers of Chankillo to the roof box of Newgrange, the solstices and equinoxes served as the fixed points in their cosmic calendar. These are the moments of celestial equilibrium, where day and night hang in perfect balance or reach their extreme limits. They are the most reliable, dramatic, and therefore teachable events in the sky's yearly journey. By building to capture these specific moments, disparate societies created a common, objective standard for timekeeping, one that any trained observer could verify without debate. The sun's path provided a universal constant, and these cultures, independently, chose to build their rituals and their societies around its most definitive turns. To capture these events, they universally employed the horizon as their primary instrument. They did not build complex mechanical devices, they used the land itself. A notch between two distant hills, the silhouette of a specific mountain peak, the gap between two standing stones, these became the fiducial marks on a giant, natural dial. This horizon-based astronomy is deeply practical. It requires no delicate technology that can break or be lost. It is always present, and it scales perfectly to the community. When the sunrise crested the heel stone at Stonehenge, everyone gathered could see it. When the Pleiades rose above a certain sacred peak in the Andes, the signal was public and undeniable. The horizon was their shared screen, and the celestial bodies were the moving pointers. This method also embedded the calendar in the local landscape. making the knowledge specific to a place and therefore inseparable from the identity of the people who lived there. Their time was literally rooted in their home. The sheer scale of their architectural investment is the third common thread, and it speaks volumes about their priority. They did not simply pile a few rocks as a marker. They moved mountains of earth and multi-ton stones. They engineered precise corridors and calibrated apertures. They leveled vast foundations and aligned entire complexes to a fraction of a degree. This was hard coding in the most literal sense. They were transferring fragile, ephemeral knowledge, the observed path of a star, into the most durable medium they could conceive, monumental masonry. The disproportionate effort tells us the alignment was not a decorative feature, it was the core function. The temple was built for the beam of light, the circle was raised to frame the moonrise. This monumental investment acted as a societal commitment, a physical pledge that this knowledge was too vital to be left to memory alone. It had to be set in stone, literally, to ensure its survival across the uncertain passage of generations. Finally, all of this implies, with quiet certainty, the existence of a specialized class of keepers. The precision of these alignments did not emerge from casual, communal stargazing. It required disciplined, nightly observation over decades, the meticulous comparison of records across lifetimes, and the authority to direct vast labor projects. Someone had to be freed from subsistence work to watch, to calculate, to remember, and to teach. Whether they were the priest astronomers of Malta, the Inca clans maintaining their Ceque lines, or the elders who knew the song lines of Australia, these individuals were the living synapses in the culture's long-term memory. They were the human mechanism that made the generational project possible. The custodians who ensured the stone calendar continued to tell the correct time. When we see these four threads, the solar focus, the horizon as tool, the monumental investment, and the keeper class, repeating independently across the globe, we are witnessing something profound. It is not evidence of a lost global civilization, but of a near-universal human capacity, faced with the same sky and the same need to predict seasons, to synchronize community, and to find meaning in the cosmos. Human minds, in isolation, converged on remarkably similar solutions. This suggests that the drive to observe, to find order, and to preserve that order for the future is woven deep into our shared nature. It reveals a shared capability for patience and foresight that we often deny our ancestors. When the necessity was perceived as absolute, whether for survival, social cohesion, or spiritual harmony, humanity proved it could think in centuries, could work for a future it would never see, and could build legacies meant not for themselves, but for the very concept of continuity. The stones are not anomalies, they are landmarks on a common path of human curiosity, a path that begins with looking up and wondering, and culminates in building something meant to outlast the wanderer. The stones and stars present us with an elegant, undeniable proof of capability, but they guard the secret of the human heart that drove it. We can map the solstice sunrise with software, calculate the lunar cycle, and admire the engineering. We can reconstruct the how with increasing confidence, yet the silent core of the mystery remains, the why. What inner fire sustained a project that demanded lifetimes of patient watching for a result no participant would live to see in full? The practical answer is compelling and certainly foundational. A reliable calendar meant survival, synchronizing planting, harvest, and migration with the unwavering rhythm of the cosmos. It was the ultimate tool for turning uncertainty into order, famine into feast. This was a science born of necessity, yet the sheer monumental scale of the effort, the artistic care in the carvings, the sacred isolation of the sites, all whisper of something more. It suggests the calendar was not merely a tool, but a testament. Aligning a temple to the sun could be a supreme act of statecraft, a demonstration that the ruler or priestly class held the very keys to time itself, legitimizing their authority by linking it to the eternal. It fused political power with cosmic order, but even this explanation may not reach deep enough. For many of these cultures, the sky was not a clock, but a living tapestry of stories, ancestors, and deities. To capture a beam of light in a dark chamber might have been seen as capturing the spirit of a god, or facilitating a journey to the afterlife. The alignment was not just observation, it was communion, a ritual act that maintained the balance between the human world and the divine cosmos. In truth, the motivation was almost certainly a seamless blend of all these threads, the practical, the political, and the profoundly spiritual, woven into a single world-view where understanding the sky was synonymous with sustaining the world. This is where our modern perspective struggles to follow. We live in an age of rapid results and short attention spans, where knowledge is often pursued for immediate application or fleeting novelty. The prehistoric mind, as evidenced by these stones, operated on a different wavelength, one of deep time. They thought in centuries and millennia, not fiscal quarters or election cycles. Their greatest works were not for their own glory, but for the continuity of their people, for the honor of their ancestors, and for the security of their descendants in a universe they believed was listening. The alignments are the durable fossil of that mindset, a mindset that could look at a star's slow drift and feel not impatience, but a sacred responsibility to mark it for those 100 generations hence. This may be the most haunting and beautiful legacy they left us, not just a map of the sky, but a mirror reflecting a capacity for patience and purpose that we are only now, in our own long-term scientific challenges, beginning to rediscover. The silent testimony of these stones forms a consistent argument across continents and millennia. From the solstice-aligned corridors of Newgrange to the lunar calibrated circles of Stonehenge, from the solar towers of Chankillo to the star shafts of the pyramids, we find a common thread, a precision that could only be achieved by understanding cycles far longer than a single human life. This was not a matter of watching the sky for a decade, but for centuries, compiling data across dozens of uninterrupted generations. The evidence points irresistibly to the existence of sustained traditions of observation, where each lifetime of watching became a single data point in a grand multi-generational experiment. This represents one of humanity's earliest and most profound intellectual achievements, the birth of long-term empirical science. It is the moment we stopped merely reacting to the world and began systematically recording its rhythms, investing in a future we would never inhabit to secure knowledge we believed was essential. The deep time perspective this required tells us something fundamental about human potential. It reveals a capacity for patience and foresight that we rarely credit to our ancestors, an ability to see oneself not as an individual, but as a vital link in a chain stretching thousands of years into both the past and the future. It speaks to the power of cultural memory, to the social technologies of oral tradition and monumental architecture that were invented precisely to defeat the fragility of individual life. And at its heart, it reflects our enduring, perhaps defining, desire to find order in the cosmos, to build a meaningful dialogue with the stars, and to leave behind a permanent record of that conversation. These alignments are more than ancient curiosities. They are a mirror held up to our own aspirations. In a world often focused on the immediate, they challenge us to consider what we are building for the people of the year 4000. What mysteries from our own age might future generations struggle to decipher? Share your thoughts on other ancient enigmas that capture this spirit of long-term thinking in the comments below.